Imagine standing at the base of a skyscraper, right? And you're watching this massive steel beam just slowly, almost gracefully, ascending hundreds of feet.
Mm-hmm.
Or maybe you've seen like a work platform extend dizzyingly high, holding technicians working on a bridge. There's immense power there, but, also immense potential danger.
Absolutely.
Today, we're kind of pulling back the curtain on the unseen safety nets that make these kinds of feats possible.
Yeah, we're taking a deep dive into the lifting operations and lifting equipment regulations 1998. Everyone pretty much calls it ELO.
LO, right?
And it's way more than just those huge cranes you see on building sites. ELO covers a really vast array of equipment. Could be anything from, say, a small patient hoist in a hospital
Right.
to gigantic telehandlers moving materials around a warehouse.
So our mission today is really to unpack these regulations. We want to explore not just what the rules are, but kind of why they exist and how they meticulously aim to keep everyone safe, especially in workplaces where lifting and lowering loads is just, well, a daily reality.
Exactly. And we'll uncover the key duties, the critical checks, and some genuinely surprising specifics, actually, about how different lifting technologies are kept in check.
And for you, our listener, whether you're working near heavy machinery or maybe you see a lift in a public space or you're just curious about how complex operations are managed safely, these regulations are surprisingly relevant.
They really are. They help us understand the unseen layers of safety that protect us all pretty much day in and day out.
Okay, let's start at the foundation then. What exactly is OLER and who does it apply to? It sounds like it casts a pretty wide net.
Oh, it absolutely does. LR places crucial duties on anyone, really. People, companies, anyone who owns, operates, or even just controls lifting equipment.
Controls it, so even if you don't own it.
Exactly. This extends to virtually all businesses where employees use such equipment, even if the business itself doesn't own it. And it's often paired with PUER. That's the Provision and Use of Work Equipment Regulations.
Ah, PUER. Yeah, I've heard of that.
Right. PUER covers general work equipment safety, things like inspection and maintenance. So the two together create a really comprehensive safety framework.
That's a very broad scope. How much of LOLER's impact is sort of about the machinery itself and how much is about the human element, how it's operated?
That's a great question, and the human element is absolutely paramount. The core of LOLER requires that all lifting operations are, first off, properly planned.
Yeah.
And planned by a competent person.
Competent person, okay.
Then they have to be appropriately supervised and, crucially, carried out in a safe manner. So it's not just about having the right kit. It's fundamentally about smart planning and careful execution.
Right. And beyond the planning and supervision, what about the kit itself? What are the sort of non-negotiable standards for the equipment?
Well, the equipment itself has to be absolutely fit for purpose, appropriate for the specific task it's doing.
Makes sense.
It needs to be suitably marked and frequently subjected to these statutory periodic checks called thorough examinations.
Thorough examinations, right.
And what's critical here is that meticulous records of these examinations must be kept. And if any defects are found, and this is a huge safety net, they have to be reported immediately, not just to the person responsible for the equipment, but also to the relevant enforcing authority.
Wow. Okay. So it's serious.
Very. This isn't just ticking boxes. It's the framework that ensures the machinery moving massive objects around you every day is doing so safely. It's proactively preventing failures before they can cause harm.
So we're talking about lifting operations and lifting equipment. What do those terms actually cover? Does that mean like everything that goes up and down, like a garage door, for instance? Would that be OLER?
Good question. No, not everything. And a garage door is a great example of something that wouldn't typically fall under OLER.
Okay.
Regulation 8.2 of OLER defines a lifting operation pretty simply. It's an operation concerned with the lifting or lowering of a load.
A load.
And that load is broadly defined. It's the item or items being lifted. And interestingly, that can even include a person or people.
A person counts as a load.
Okay.
And lifting equipment itself. What classifies as that specifically?
So lifting equipment means any work equipment specifically designed for lifting and lowering loads. And importantly, this includes all the associated accessories too. Things used for anchoring, fixing, or supporting the equipment.
The whole system.
Pretty much, yeah. The whole system.
Can you give us some real-world examples of equipment and accessories, things covered by OLER that people might actually see?
Sure. For equipment, think overhead cranes, obviously. patient hoists in healthcare settings,
Right.
motor vehicle lifts in a garage, vehicle tail lifts on delivery trucks, even those building cleaning cradles you see on skyscrapers, goods and passenger lifts in offices, telehandlers, forklifts,
So quite a range.
a huge range.
Mm.
And then for accessories, these are the vital links, right? Fiber or rope slings, chains, single leg, multiple leg hooks, eye bolts, spreader beams, even specialized magnetic and vacuum devices. We'll actually get into those later.
Okay, cool. So if those examples are covered, what doesn't fall under a lower's specific rules? What are some of those exceptions that might surprise us?
Yeah, that's important too, because some things that seem like lifting devices aren't governed by these particular rules.
Mm.
So for instance, those simple pallet trucks that only lift a load clear of the ground, generally not a lower.
Ah, okay.
Same goes for roller shutter doors, escalators, moving walkways, even dentist chairs.
A dentist chair, really?
Yep. While they involve some vertical movement, they fall outside a lower's specific scope.
Yeah.
But, and this is crucial, fewer, or the main Health and Safety at Work Act, the HSW Act, might still apply if they're used at work. So there are still general safety standards.
Right, so there's always some level of safety oversight.
Usually, yes.
Okay, you've outlined the core rules, but I imagine the real detail and the complexity lies in how each individual lift gets planned. Can you walk us through that? How does that deep thinking translate into a safe operation?
Sounds like there's a big spectrum of planning needed. There absolutely is. The planning phase is critical, and its depth must always reflect the complexity of the operation. I mean, even simple routine lifts, like with a forklift, they need some minimal on-the-job planning by trained, competent people.
Right.
But for the really complex stuff, say a tandem lift using multiple cranes for an enormous load, well, that demands sophisticated, detailed written plans. You need high levels of expert input, especially trained personnel. The planning is always directly proportionate to the risk.
So what are some of the most critical factors they look at in that planning process? What are they trying to, head off?
The plan has to address all the foreseeable risks. So things like working under suspended loads, which you really want to avoid, but if you can't, you minimize the risk.
Okay.
Ensuring operators have clear visibility, how to properly attach, detach, secure loads. They also consider the environment wind, for instance, the location itself, preventing overturning or proximity hazards like overhead power lines.
Power lines, yeah, that's a big one.
Huge. And there are specific considerations for lifting people, or situations where overload might be a risk. It's about anticipating pretty much everything that could go wrong.
And the equipment itself has to be incredibly robust for the job,
Yeah.
right? You can't just use any old piece of kit for these big lifts.
Exactly. The equipment must be of adequate strength. It needs an appropriate factor of safety against failure.
After safety.
Yeah, think of it like building an extra strength, like designing a bridge to hold 5 times the heaviest truck expected. That extra capacity is your built-in safety net against the unexpected. And what's interesting is that this factor is often significantly higher when you're lifting people.
Which makes total sense.
Reflects the increased risk to human life, exactly.
And positioning must be absolutely key, too. How do the regulations deal with that to minimize risk?
Yeah, lifting equipment has to be positioned or installed to minimize risks.
Yeah.
So reducing the chance of the equipment or the load striking someone,
Yeah.
or the load drifting, falling freely, or being unintentionally released. They
Yeah.
use measures like multiple ropes, hydraulic check valves.
Check valves.
Yeah, they're basically non-return valves. They stop hydraulic fluid flowing backwards.
Yeah.
So if a hose bursts, the load doesn't just plummet.
Ah, clever.
Or nets for palletized loads, things like that, all designed to stop loads falling if something goes wrong.
Given all these variables, how critical is something as seemingly basic as clear marking, like the safe working load? Do people misunderstand that?
Oh, it's vital.
Yeah.
All lifting equipment, including accessories, must be clearly marked with its safe working load, the SWL. That's the absolute maximum load it can safely lift.
Okay.
And a common misconception is that SWL is always a single fixed number. But if the SWL changes with the configuration, like an engine hoist hook might lift less when it's extended further out,
Right. Yeah.
that information must be clearly visible.
Yep.
And equipment used for lifting people. That has to show both the number of people and the SWL.
Both. Okay.
And crucially, equipment that's not designed for lifting people, but which someone might mistakenly use that way. That has to be clearly marked to say, do not use to lift people. Helps prevent dangerous misuse. It's a fundamental visual safety cue.
So how does all this come together in terms of practical, ongoing safety? What's the sort of backbone of ensuring everything stays compliant and safe day to day?
Well, that brings us nicely to the thorough examination. You could call it the lifeline of lifting equipment safety.
Okay.
It's a systematic, very detailed inspection of the equipment and all its safety-critical parts. It's carried out at specified intervals by a competent person.
That term again, competent person.
Yes, and it means someone with the right practical and theoretical knowledge to spot defects
Mhm.
and, importantly, assess how significant they are.
Oh,
And it's vital that this person is independent. They shouldn't be the same person who does the routine maintenance. You need that impartial, critical eye.
right. Avoids conflicts of interest. So when are these thorough examinations actually required? Is it just like a yearly MOT check, or are there specific triggers?
No, it's more nuanced than that. There are several key times. Definitely before first use, unless it has a valid declaration of conformity that's less than 12 months old and the equipment wasn't assembled on site.
Declaration of conformity.
That's basically the manufacturer's guarantee.
Right.
A legal document saying the equipment meets all the essential safety standards when it leaves the factory.
Got it.
But if the equipment was assembled on site, say a big crane, it must be examined after assembly before it's used.
Okay.
It's also required after assembly and before use at each new location. Think of moving that tower crane to a different site.
Makes sense.
And critically, regularly while it's in service, especially if it's exposed to conditions that could cause deterioration, which, let's face it, most lifting equipment is.
Yeah, weather, wear, and tear.
Exactly. And finally, they're required following exceptional circumstances. That could be damage, maybe it's been out of use for a long time, or if there have been major modifications.
Right. And what are those standard frequencies for the regular in-service checks?
Okay, so unless there's a specific written scheme of examination that says otherwise, the standard periods are every 6 months for lifting equipment and accessories used to lift people.
6 months for people.
Yes. Also, every 6 months for all lifting accessories,
Yeah.
regardless of what they lift.
All accessories. Okay.
And then every 12 months for all other lifting equipment.
Got it. 6, 6, and 12. What happens if, something serious is found during one of these examinations? What's the immediate fallout?
Right. Well, if serious defects posing an imminent risk are found, the competent person has a legal duty to immediately report it verbally to the duty holder.
The duty holder being the person responsible.
Exactly. The person or company legally responsible for the equipment's safety, usually the employer or owner. This verbal report must then be followed up immediately with a written report.
Okay.
And a copy of that written report must also be sent to the relevant enforcing authority, like the HSE. And the absolutely critical part,
Yeah.
the equipment cannot be used again until that defect is properly fixed.
No exception.
No exceptions. It highlights just how serious these findings are. Imagine finding a small crack in a crane hook, tiny defect, potentially catastrophic failure under load. This immediate reporting system is literally designed to stop disasters before they happen.
So the thorough examination is this specific legally required check. How does that differ from, say, the checks an operator might do every morning before they start using a forklift?
Yeah, that's a really important distinction. While the thorough examination is this formal statutory inspection, those daily or weekly pre-use checks and inspections done by the operator are also vital. They're actually a requirement under PURE, the General Work Equipment Rules.
Oh, okay.
So they work hand in hand. The thorough examination is like the deep dive periodic health check by an independent expert, while the pre-use checks are like the driver doing their daily walk-around check looking for obvious issues before starting work. Both are crucial for ongoing safety.
Okay, this is where it gets really interesting for me. Let's talk about some of the truly specialized lifting equipment. You mentioned magnets and vacuums earlier. How do the regulations adapt to these different technologies, especially when you're lifting people? Each must present its own unique challenges, surely.
Oh, absolutely. Each type brings its own set of challenges and, frankly, some fascinating safety solutions. Let's start with A, lifting people, as you mentioned.
Right. What's the biggest difference, the biggest safety concern when you're lifting humans instead of, say, a pallet of bricks?
Well, fundamentally, it's the drastically increased risk of serious or fatal injuries. When people are lifted, think mobile elevated work platforms, MEWPs, or construction hoists.
Yeah, cherry pickers and things.
Exactly. There's just a much higher chance of things like collisions, overturning, equipment failure, having devastating consequences. So naturally, this demands much higher standards of safety in everything. Design, manufacture, use, maintenance, inspection, and that thorough examination we just talked about.
So the equipment has to be specifically designed for it.
Absolutely. Equipment must be specifically designed for lifting people under the supply of Machinery Safety Regulations, 2008. And it has to be clearly marked as such. You can't just, sling a cage onto any old crane hook.
Sounds like an area where you absolutely cannot cut corners.
Precisely. Using equipment that isn't specifically designed for lifting people should only happen in genuinely exceptional circumstances, like for emergency rescue purposes.
Okay.
And even then, you need additional stringent safety precautions. For example, only using base lifting machines that have those check valves we mentioned and locked tilt functions to prevent accidental tipping. And regardless of the design, all equipment used to lift people must be thoroughly examined every 6 months. The stakes are just too high.
Makes perfect sense. Okay, moving on. You mentioned magnetic lifting devices.
Yes.
These are used a lot in metal processing, aren't they? Lifting big sheets of steel without needing hooks or slings.
That's right. They're used extensively in industries like steel stockholders, manufacturing, recycling, anywhere dealing with large ferrous materials. It avoids damage from slings and speeds things up. But the main hazard, as you might guess, is the material falling.
Right. Power cut or...
Exactly. Power loss or just incorrect application not getting a good magnetic grip.
And I think I read there's another less obvious risk with these, something about the magnets themselves.
You're right. There is. Electromagnetic fields, EMFs.
Ah, EMFs.
Yeah, they're an inherent part of powerful magnets, and they can be a health risk. They can potentially interfere with active body implants like pacemakers or insulin pumps.
Wow, okay. Didn't think of that.
And they can even disrupt sensitive electronic communication and control systems sometimes. So it's a silent hazard you wouldn't necessarily associate with just lifting something.
So how do they manage these risks? What specific safety measures are built in or required for magnetic lifters?
Well, several things. The equipment has to have clear indicators, lights, or gauges to show when it's actually magnetized, or if it's maybe operating at reduced power for some reason.
Okay.
For battery-powered magnets with a safe working load over 20 kilos, there needs to be an automatic warning, audible or visual, that activates at least 10 minutes before the battery runs down to the point where it might release the load.
A 10-minute warning, right?
Yeah. And for magnets running off an external power supply, they need a standby battery backup that can hold the full SWL for at least 10 minutes if the main power fails, plus an automatic warning for that power failure too.
So backups for the backups?
Pretty much. And crucially, releasing the load should require 2 distinct actions from the operator. You can't just accidentally bump one lever or button and have tons of steel drop.
Makes sense. What's maybe counterintuitive about these devices? You might think a huge magnet just lifts anything metal, but I guess it's not that simple.
No, definitely not. What's often surprising is how easily their lifting capacity can be affected. You think big magnet, big lift, right? But something as simple as a layer of paint, bit of rust, dirt, or even just a small air gap because the surface isn't perfectly flat.
Ah, the air cap.
Yeah, they can dramatically reduce the magnetic force and its lifting ability. You also have to consider the material itself. Some stainless steels aren't very magnetic, for example.
Right.
Its weight, obviously, but also its thickness, its shape.
Yeah.
Even the temperature matters. Ferrous metals start losing their magnetism significantly, around 700 degrees Celsius. And the flexibility of the load. A thin sheet might actually start to peel off the magnet before the whole thing lets go.
Wow. So specific operating practices are absolutely essential then, beyond just having the right machine.
Totally. Essential practices include making sure you get good, clean contact between the magnet and the load.
Yeah.
Never, ever exceeding the SWL for that specific material and configuration. Maintaining clear exclusion zones below the lift path.
Keep people away.
Keep people well away. And transporting loads at the lowest possible height, ideally no higher than maybe 1.5 meters above the ground, just to minimize the danger from a fall if the absolute worst should happen.
Okay. Fascinating stuff. Lastly then, let's talk about vacuum lifting equipment.
Right.
These are the ones using suction cups, right? Typically for big, flat things like glass panels or concrete slabs.
Exactly. Widely used for lifting materials with flat, smooth surfaces. Glass, sheet metal, concrete sections, stone slabs. And there are 2 main types you see. First, there are vacuum lifting tubes, or VLTs. These use a sort of collapsible tube with suction pads at the bottom. The clever bit is that the vacuum system both grips and lifts the load. And the design usually ensures the gripping force is at least twice the load force.
Twice? Why so much?
It's a safety feature. It means that even if the vacuum level drops a bit, it still has more than enough grip. And if it drops to a critical level, the load is automatically lowered safely rather than just dropping.
Ah, okay. Smart. And the second type?
The second type are vacuum lifting attachments, or VLAs. These are basically just the suction pad unit, and they attach to an independent lifting machine, like a crane or a hoist. They only provide the grip. The crane does the actual lifting.
Got it. And the main hazard sounds pretty similar to the magnetic lifters dropping the load.
It is, yeah. The principal risk is the load falling due to vacuum failure, maybe power loss to the pump, or just improper use, like trying to lift something with a rough or dirty surface.
So what are their specific safety features, similar warnings, and backups?
Yes, quite similar in principle. Audible and visible warnings are required if the vacuum pump fails or if the vacuum level drops below about 80% of the normal working level.
Okay, an 80% threshold.
Yeah. Powered VLA should also have a vacuum reservoir, a tank. Essentially, they can hold the load securely for at least 5 minutes if the pump fails, giving time to lower it safely. And for high lift applications, generally meaning above 10 meters, things like secondary safety arms or strong nets are often required as an extra physical backup to prevent the load falling if the vacuum is completely lost.
Right. What about restrictions where are they definitely not suitable?
Well, clearly, they're unsuitable for lifting loads over people's heads.
Obviously.
Or in any situation where a sudden load drop could have really dangerous consequences like rupturing steam pipes or damaging critical structures. And they absolutely rely on clean, smooth, non-porous surfaces for the suction pads to work properly. Dirt, dust, water, ice, or just an uneven surface can seriously impair the lifting capacity or stop it working altogether.
So surface preparation is key.
Absolutely critical. And what about their examination frequency? Do they count as accessories? It depends. If a VLA is an accessory that gets moved between different lifting machines, then yes, it requires a thorough examination every 6 months, just like other accessories. But if it's permanently fixed to one specific crane, then it's generally considered part of that crane and follows the crane's 12-month examination interval.
Yeah.
So it loops back into that whole OLO or framework we discussed. Regular independent checks are always a priority.
So wrapping this up, what does this all tell us? We've seen how OLOR provides this really comprehensive safety framework. It goes from these broad planning principles right down to incredibly specific details for niche technologies like magnetic and vacuum lifters.
It really does. And I think it's a testament to how complex industrial tasks can be made safe through really meticulous regulation and constant oversight.
Yeah. And if we connect this back to the listener, I mean, understanding OLOR gives you, I think, a profound new appreciation for all that hidden expertise and the diligent checks that are happening constantly behind the scenes in so many industries.
Definitely. It ensures those massive movements we see happening around us are controlled and safe. It really makes you realize how much thought goes into the seemingly simple act of lifting something heavy.
Absolutely. It's not just about the big machines and industrial sites either, is it? I mean, consider a simple car jack, something you might use in your own driveway. Did you know that even that seemingly simple piece of equipment, if it's used in a work setting, say, in a garage,
Yeah.
it actually falls under the scope of LO-LAIR and the supply of machinery safety regulations? It needs that declaration of conformity from the manufacturer and potentially needs an initial thorough examination before its first use at work.
That's right. Even the humble car jack.
So what does that tell you about just how pervasive these safety regulations are, even for tools we might completely take for granted in our daily lives? Makes you think, doesn't it?